When we begin low-level design for any system, one of the first and most crucial steps is to ask ourselves, what are the important objects in our system? This question sets the foundation for everything that follows. For instance, in an e-commerce platform, you might immediately think of objects like user, order, product, payment, address, and price. But simply listing nouns from requirements isn't enough. We need a structured way to decide which of these should become entities in our design. Let's explore what makes an object worthy of being an entity. It's a common misconception that every noun in your requirements should become a class or an entity in your system. However, that's not the case. If we blindly turn every noun into an entity, our design becomes cluttered and hard to maintain. This is where the concept of an entity comes in. An entity is not just any object. It represents a business concept that the system must treat as a distinct thing with its own identity and lifecycle. So, how do we decide what qualifies as an entity? Let's break it down. Entity is a business concept that the system needs to identify and track as a unique thing. It has its own identity and a lifecycle that the system must manage. For example, in our e-commerce system, an order is an entity. Even if two orders contain the same products and have the same total amount, they are still different orders. The system must be able to distinguish between them. This unique identity is what makes an object an entity, not just its attributes. First question to ask when identifying an entity is, does this object have its own identity? For instance, consider order 101 and order 102. Even if both orders are for the same products and amounts, they are still separate and must be tracked individually. The system needs to distinguish between them, which means each order has its own identity. This is a key reason why order is modeled as an entity. Second important question is, does this object have its own lifecycle? Take the order example again. An order goes through several stages: created, paid, shipped, delivered. The system needs to track the same order as it moves through each of these stages. This lifecycle management is another reason why order is an entity. The same logic applies to other objects like user, payment, and product, each with their own identity and lifecycle. Let's look at some concrete examples. In our e-commerce system, user, order, payment, and product are all entities. Each has a unique identifier, like user ID, order ID, payment ID, or product ID, and each goes through its own lifecycle. For example, a user might register, update their profile, or deactivate their account. A payment might be initiated, processed, or refunded. These are all tracked individually by the system, reinforcing their status as entities. Not every object with a name is an entity. Consider price. We usually don't care about the identity of a particular price object. We care about its value. So price is typically modeled as a value object, not an entity. The same goes for address, unless the system allows users to save and manage multiple addresses independently. If address is just a value, it's a value object. If it has its own identity and lifecycle, like address 101 for home and address 102 for office, it may become an entity. The key takeaway is that identifying entities is not about finding every noun in the requirements. It's about finding concepts that the system needs to uniquely identify and track through their lifecycle. Whether something is an entity or a value object depends on the specific requirements and how the system interacts with that object. This distinction helps keep your design clean, focused, and maintainable. Once you've identified your entities, the next step is to design their attributes, behaviors, and relationships. This forms the backbone of your system's low-level design. By focusing on entities and their life cycles, you ensure your system can accurately represent and manage the real-world business concepts it's meant to handle. This approach leads to a robust, flexible, and scalable architecture that's easier to maintain and extend as requirements evolve.